Cool. Welcome, everyone, to Stylus on the web. I'm Tom Buckley. I'm a product manager on Chrome OS, and we'll be presenting with Glenn.
Yeah, I'm an engineer on some of the projects that we'll be talking about.
So yeah, there are many platforms that support Stylus beyond Chromebooks, Windows devices, Surfaces, etc., iPads, Android tablets, and in many of those cases, developers turn towards native solutions to build a great Stylus experience. But we have been pushing on web standards to continue improving this, and wanted to sort of talk through a few of them. In particular, there's a app that we've worked on that's built in on Chromebooks called Chrome Canvas, canvas.apps.chrome, that uses some of these to provide a nice low latency experience. Glenn, next slide. Cool. So the first thing we're talking about is desynchronized canvas. Latency is incredibly important to any Stylus application, and I guess in particular perceived latency. So the distance between the tip of your pen and the line that's being drawn. So next slide, please. We have this Desynchronized Canvas API that we've used to help improve this. And this is used in apps like Chrome Canvas, shown here. When you create a context for a canvas, whether it's 2D or WebGL, you can pass this desynchronized attribute. And what that tells the browser is that it's OK to render the contents of this canvas out of sync with the rest of the page, and allow it to skip any buffering and compositing and render to the page as soon as possible. And from us, this is we give that canvas a hardware overlay, and any changes that you make to it are sort of immediately scanned out to that to the screen. And then that can lower your latency quite significantly. And then with that, you can add in prediction, and in particular, there's a get predicted events function on a pointer event that can allow you to reduce that perceived latency from the 32 milliseconds that you would get down to 10 milliseconds or so, which really is where all of the best Stylus experiences are today. Next slide, please. So just to sort of visualize this, this is the sort of normal stack for taking input events from a Stylus sensor all the way through when they're going to be scanned out to the display. And your application is responsible for maybe 2 milliseconds of those, but it's very easy to get to 100 milliseconds of latency end to end. And so what this API lets you do is particularly focus in on that. Well, GPU is up to you. It tends to be a bit slower than just raw CPU rendering, but in particular the multi-buffering and compositing layers are what this allows you to skip and again write directly to the screen. So next slide, please. Yes, we cut those out. Next slide. And we'll end up with, again, in that 30-ish millisecond range. With prediction, you can then get down to the sort of ideal 10 milliseconds or so of latency. So that's desynchronized attribute and how to get low latency canvas on the web. Now I'm going to hand it over to Glenn to talk to you about a few more Stylus APIs.
Yeah, so first one up is Handwriting Recognition API. I've seen some of the people who worked on this are in the call as well, but correct me if I say anything wrong. But this is essentially to let you do handwriting on the web using hardware recognition. So basically, when you call this API, it will go to the hardware recognizer instead of doing some sort of recognizer that you could implement yourself in JavaScript or WebAssembly. This means that you can get much faster predictions and lower latency and stuff like that. We are trying to bring this to Origin trial in M92 for Chromebooks, hopefully coming to wider Chrome shortly after. And the way it sort of works from a technical side is you basically make this handwriting recognizer. You can put in some constraints on the recognizer, like which languages you want it to recognize. And then you just pass in your strokes and points into the recognizer, and then you can ask it for a prediction of what text it thinks you've written. You can add extra parameters into the hints as well. So you can say, like, if you have specific words that you expect the user to be typing or something like that, or you want a certain number of predictions, you can ask it for those sort of things as well, if the underlying hardware recognizer actually can do that. That's how that works. Another thing that I've been working on is just a declaration for web apps to basically say that they are note-taking apps and have a way for them to integrate with operating system level note-taking functionality. So a lot of operating systems these days have some sort of special UI for connecting to create new notes in some note-taking apps. So there's a way for getting that into PWAs. For example, in Chrome OS, we have this Stylus note-taking or Stylus tools menu in the tray, and you can create a note from there. So if you have a web app that has this note-taking URL declared, then the user can select that as their note-taking app for the operating system and create a note, which just launches that URL. Yeah, hopefully that's in the M93 as well. And finally, something that is sort of in progress at the moment is a Lockscreen API. So this is for trying to bring web apps to, hopefully there's time for questions. We're trying to bring web apps to the lock screen. Basically, you can similarly declare something in your web app manifest that says, I want to be able to be used on the lock screen. And then we have a way of taking that web app, running it in some isolated profile on the lock screen. So for example, you could take a note without needing to actually fully unlock your device and go and create the new note. And then we needed some way of communicating back from the lock screen back to the main profile app. So there's an API for sending that data. Looks something like this. So you have a URL that you declare as somewhere within your app that you can launch on the lock screen, but of course it won't launch with any of your user data because it's in a separate profile. And then from that lock screen, you can send and receive basically just a key value store of data that you want to share with the main profile app. So in this way, you could send just the note data back to the main profile app without having to share everything. Cool. I think that's everything. So we do have time for questions. Samuel.
Hi, question about the handwriting API. So is it agnostic of vector versus bitmap, or is it kind of optimized for bitmap right now?
I don't know.
So
I don't know what you mean. Sorry, Tom, do you know?
It's using the actual stroke points. So you pass it these stroke objects that are layered, you add points as they come in to a stroke object, pass that to the API or set of strokes to the API, and then it'll tell you what's recognized. So it's not looking at a bitmap as part of it.
So okay.
Yeah, it really depends on the backend you are using. I think the current backend will renormalize, re-smooth, and resample the strokes. It will generate their own strokes based on the input strokes. So it should not matter very much that what you input is.
So if we make like Canvas faster, will we need to make SVGs faster as well if that gets used?
These can be handled separately. So like even as your app is rendering to the low latency canvas, it can be recording an array or creating these stroke objects based on the input points that it's rendering to the canvas, and then pass those to the recognizer to be recognized. So no SVG needs to be generated as part of this. If you, at the end, you could also have I've seen some apps that take an approach where they'll sort of have a transparent overlay with that low latency canvas. As soon as the stroke is finished, they'll convert it to SVG or something like that, and then just have it be part of the DOM.
Okay, thanks.
Eugene?
So actually, I didn't notice that David's in the room as well. I'm curious to know if the Chrome OS folks have had a chance to investigate the web annotations efforts. Microsoft, the previous incarnation of Edge, the one before they came over to Chromium, had a capability of doing a markup or annotation. And to me, that's a natural thing that you want to do with a stylus. If you're looking at a web page, you probably want to scribble on it. And I'm curious to know if you folks have had a time to investigate into that.
I can only speak for Chrome OS. I think that's something we're interested in. I think normally, this isn't something that the page should need to support. If I want to mark up a newspaper, I should be able to do that without them needing to support Stylus. And then the question is this just a browser feature and we output a image or a PDF at the end, or is it a note-taking app and that intent that Glenn mentioned earlier, like should we be able to sort of say, once I finish marking up or annotating this web page, it goes into my favorite note-taking app of choice to be saved as a note so I can refer back to it later. Definitely, as PM for Stylus on Chrome OS, something I'm really interested in, would love to see. I think that was a great feature of Edge.
Brian has been waiting patiently.
Would it be possible to quickly rewind to the slide that had the recognition results? Yeah, so what the extra fields is a confidence level or?
So I believe that is kind of flexible so that other things can, different recognizers can provide different extra information there. I believe the current recognizer on Chrome OS does segmentation of the image into text letters, I think.
I just wanted to note the similarity, strong degree of similarity here with speech recognition. And as a web author, I appreciate when we have consistency of similar things. So something that would be nice to consider is if we could sync those up, because both that has a similar thing where you get a transcript property and a confidence property in that result. I mean, otherwise it looks a lot like this.
Currently, I don't think there's a confidence score because as a deep learning or as a machine learning model, the confidence score is not very useful as an absolute number, and it can also be confusing may mislead the client. So I think we currently just give the rank, which is the best possible one, a second best possible one, and without the exact confidence score.
It seems like you would have that for speech as well, though, right? So I don't know, for whatever it's worth.
Yeah, this is something that we did discuss a lot back and forth, and obviously this is going to an origin trial, and it can still be discussed more openly. I agree that it's like if the speech one has it, then why shouldn't this have it? And it's, well, these were designed by different people at different times, so maybe we can try to get a degree of consistency. But from my perspective, consistency should come from if there's it shouldn't be that the features have to match, because it may not make sense for this feature to exist here. But if we do have a feature, then we should have, for example, consistent naming conventions and consistent, the way that you pass data structures around as much as possible. So that's more what I would be interested in, making sure that we're on track with speech recognizer and those other recognizers. And it is something we looked at when we started designing it, was using those other recognizers as a model.
I mean, I feel like it could go the other way as well, because like it would be nice if we had good promise-based APIs for web speech.
Yeah, I think it's really a drawback of machine learning model. The numbers are really meaningless in absolute meaning. I mean, it doesn't have any absolute meaning. It doesn't have any meaningful probabilistic explanation. It's just a meaningful in relative comparison, which means in ranks compare with its own outputs. Yeah.
Is it not the same with speech though?
Yeah, I think so.
I don't know. I don't know enough about it, but
I think should be 99% true. Yeah, for the speech too. Yeah, but I'm not sure. I'm not sure. But yeah, but I think it's the nature of every complex machine learning model. Yeah.
It might be the case that we look back at speech and we say, like, we aren't the people responsible for the speech API, so don't exactly know. But we might look back at speech and say that was a mistake to put the confidence scores in there because they're meaningless. Well, let's say the ML experts tell us that they're meaningless. Well, we can't take them out of speech recognition. We shouldn't put them in handwriting recognition. So that's just a point where we end up with a point of inconsistency just due to historical reasons. Just like how we might not have a promise-based API in older APIs. We're not going to design new APIs without promises for consistency.
Should we move on? Robert.
Yeah, I was curious about the desynchronized canvas change. So is this 2D canvas only? Okay, cool. So that's 3D canvas too.
Yes, 2D and 3D. Yeah.
And like the benefit is reduced latency. Is it also possibly faster? Should games be using this? Like, what is the full extent of this?
The full extent. So it can be faster. It really depends on the use case, and in particular, one of the downsides of using it is tearing. So you're able to write to this all the time. The display will start scanning out, and if you write to it halfway through that scan out, it's just going to keep reading the memory. You're writing directly to the memory that's being scanned out. So it's great for writing, which is usually small, purely incremental bits of ink. But for a video or a video game where the whole screen is updating, or even a canvas, we try to, one thing we'd like to add is a way to dynamically turn this off so that as you pan or zoom the canvas, it doesn't trigger any tearing.
Right.
That is a downside today.
So it's not double buffered.
Correct. It's up to the app to do anything like that.
Would there be like an alternate API to have double buffering but be desynchronized from the main thread update? Like that might also be advantageous for the cases that you were talking about, like games and video players and stuff.
Very possibly. I would defer to people who know more about the graphics stack and gaming than myself. But at least for Stylus, where we do want to try and eke out every last millisecond, this was a worthwhile trade-off.
Yeah, it makes complete sense.
But yeah, there might be wins there for sure.
All right, Riley.
I think this was mostly related to the last discussion on like what those extra parameters were. So I did did some work previously on the various shape detection APIs, and one of the APIs that we have not shipped yet is text detection, and specifically because there wasn't enough consistency between platforms in terms of what capabilities and also types of results text detection APIs on various platforms could provide. And so it's definitely a warning to be careful about what you promise and specify in the API, because it needs to be something that could be reasonably implemented across multiple platforms. I think like one of the issues there was that on some platforms, text detection is only really supported for languages that use the Latin alphabet. So like, double check, does this API work if you're writing, Chinese characters? What might be different? Do you want to explicitly call that out as not currently supported and do a V2 for that, etc.
One of the things I didn't put on this slide is there's also a way of querying the recognizer. And so you can essentially ask it, do you support, say, Chinese text? And get a response there. So you at least can know from a web developer perspective. But yeah, it's totally possible that some platforms just won't support certain features.
I think the important thing is to make sure that there's a that the minimum sort of viable feature set is one that would be reasonably useful for applications. So you don't end up with applications that are sort of fundamentally broken in some locales because the feature set isn't supported or is supported. Design the API so that things gracefully degrade, I think is kind of the point.
To answer your question that just saw pop up about finding out more about this, each of these has an explainer up, so I can link them. Oh, Matt's doing it. Excellent. Please go and add comments and issues there if you have any thoughts.
Excellent. Thank you so much.
Were you specifically after the handwriting one?
Yeah. Yep.
Okay, great. You can just find them by searching as well. All right, Jimmy?
Have you guys considered using like a AI model or something for prediction? Like,
that is what this is.
No, I mean like not handwriting. I mean for the desynchronized canvas prediction, so latency. Because right now I've tried to use desynchronized canvas with the prediction API, but so far like anything beyond like a couple points is not really accurate, or it's like jiggling a little bit. And I'm wondering if like to improve the user experience, like is there like some kind of AI model to predict actually where? Because I couldn't find anything related to using AI models for input prediction. So
yeah, so far the best luck that we've had, and I'll admit to not being an ML expert, so ML experts may have a better answer than me, but we found sort of simple physics-based models to be the most reliable for at least short durations of 8 to 16 milliseconds of prediction. I'm sure there could be ML models that do better, but for the size trade-off and the quality, we found that those were reasonable for what we wanted.
Okay, thanks.
We only got a minute or two left, so I guess real quickly, Brian.
Oh no, that was my question got answered with the link, but I'll take
link.
the opportunity to say the explainer has some great stuff in it. So thanks, I'm already looking at it.
Cool. And Rick?
Looks good.
Hey, the desynchronized canvas feature has been shipped for some time, right? Is there somewhere? I was just getting my Pixelbook stylus out and trying to play with like Keep or something. Can I play with this? Can I see it in action?
Yeah, Keep should have it. Canvas.apps.chrome is that, and it should be a default app. And yeah, we're trying to get it in more places. There are some challenges to using it beyond what's shown in this slide that we're trying to make easier through libraries. So keep an eye out for those as well. But yes, for apps, Chrome Canvas, Google Keep should both have it. I think there might be others at Google, but those are the ones I'm aware of.
Thanks.
Great. I think we answered all the questions. So thanks everyone for coming.
I really like that you added a query for offline capabilities. That's really good.
Thanks, everyone.
Bye.